yesterday we learned 3 ordered pairs, okay? And they are, we're going to put them in the smack dab in the middle so we don't forget them. The 3 ordered pairs that we need to remember are 1 over b, comma, negative 1, 1, 0, b, comma, 1. These are always the ones that we are going to use, okay? So today what we're going to do is, yesterday we graphed the parent function. We would find b, we plug it in, we would graph it. Well, not all functions are nice parent functions. They have numbers in front of them. They have things after them. So what we're going to do today is we're going to what we call manipulate these 3 ordered pairs so that we can graph it. So everything starts with these 3 ordered pairs. Then it's up to you to remember all the little details, okay? So, you ready? Here we go. So the first one we're going to graph is f of x equals 2 times log base 3 of x minus 2. So anytime you get a problem like this, the first thing you need to determine is what your b is. So what is your base in this problem? 3. So my b is 3. So now what I'm going to do is I'm going to write my ordered pairs with the 3. So the first one would be 1/3, comma, negative 1, 1, 0, 3, 1. That's what it would be if it was the parent function. But this is not a parent function. We know it's not a parent function because there's a number in front of the logarithm and there's something after the logarithm, the log. So this number right here changes the y by multiplying. It's called what we call a dilation. It either stretches it or it compresses it. Okay? So the number in front of the log either stretches it or compresses it. So we're going to multiply all of our y's by 2. So we're going to multiply 2 times y. One-third stays. What is 2 times negative 2? I'm sorry. What is 2 times negative 1? Negative 2. 1 stays. What is 2 times 0?
0.
3 stays because that's an x. What is 2 times 1?
2.
Okay, so that took care of the front number. This number right here, it says minus 2. This number we're either going to add or subtract. But remember, like even with parabolas, when it's inside that parentheses, it's the opposite of what we think. Here we want to add, we want to subtract 2, right? But it really is, we're going to add 2 to the x values. So again, this number inside the parentheses, you're either going to add it or subtract it to the x values. So this affects the x values by adding and subtracting. So we do the opposite. Since it says minus 2, we're going to add 2 to the x's. So what is 2 plus 1/3? 2 and 1/3. The y does not change. Oh, yes. There we go, right there. So I apologize for that. So I'm going to add 2. So 2 plus 1/3 is 2 and 1/3. The y stays the same. What is 2 plus 1? Y stays. 2 plus 3? 2 plus 3 is, and then the y stays the same. And now we're going to graph it. These are our final ordered pairs. Okay, so 2 1/3, -2. So 2 1/3. 2 1/3, -2. It's like right here. 3, 0 is here. 5, -. You guys, why did I do that? I did that again. That 2 did not change. I accidentally changed it. 5, 2. And there we go. I'm not looking for perfect because, you guys, nothing that we're going to graph in exponential is going to be perfect. Okay? Exponential logarithms, nothing's going to be perfect. Okay, so again, let's just make sure. The number in front of log, you're going to multiply, only the y's. The number in the parentheses affects the x's. You either add or subtract it. And now I'm going to add a k, and what do you think k is going to affect? The k is going to affect the y's because the k moves it up or down. So the only one that affects the x's is inside. Okay, ready? So, what is my b? Okay, so what's my original order pair going to be? It's 1 over 1/2. So what is 1 over 1/2? It's 2, you guys. Anytime you put 1 over a fraction like that, the denominator is going to become the numerator. This one stays the same. And then this one is 1/2, 1. This is what we're going to manipulate now, okay? This is what we're going to change. We always start with our original, and now we're going to change it. The 1/4 does what? Yep, so we're going to do 1/4 times y values. That means the x's are going to stay the same. So 2, what is -1 times 1/4? What is 0 times 1/4? And what is 1 times 1/4? Okay. So that took care of the 1/4. Now the 3. The 3 affects which one? The x. And it says addition, so what does that really mean? So we're going to take the x values minus 3. So what is 2 minus 3? What is it, 2 minus 3? -1. The y stays the same. 1 minus 3. One minus 3. One half minus 3. Okay, last thing, and then we'll graph them tomorrow if we have to. Okay, that 5, now it's the y value minus 5. That means the x stays the same. So what is negative 1/4 minus 5? You guys are the same sign. What is 0 minus 5? 0 minus 5. Okay, so 1/4 minus 5 is negative 4 3/4. So let's just make sure we understand this. The 1/4 we multiply the y's by. So 1/4 times the y values. That's how I got negative 1/4, 0, and 1/4. This number is subtracting from the x value. So 2 minus 3 is negative 1. 1 minus 3 is negative 2. 1/2 minus 3 is negative 2 1/2. This number right here, since it's subtracting, because this moves us up or down, we're going to take the y value minus 5. So the x's stay the same, so negative 1/4 minus 5 is negative 5 1/4. 0 minus 5 is negative 5. And 1/4 minus 5 is 4 3/4. And now what we're going to do is we're going to graph it, okay? I'm not looking for perfection, just looking for a semblance of a graph. So negative 1, negative 5 1/4 is probably right about here. Negative 2, 5 is here. Negative 2 1/2, negative 2 1/2, 4 3/4. It's probably here. And we're just going to make our little graph like this. And there we go. It's not perfect, you guys, but it's estimating and we're doing good. So again, you just need to pay attention to those. The number in front multiplies the y's. This number either adds or subtracts the x's. This number either adds or subtracts the y's. Good luck, guys. Thank you.